Hello students, what is CUET? CUET is Central University Entrance Test for Undergraduate Courses 2024. This is a very good platform to take admission in prestigious universities. What is the pattern of this test? This is the pattern of this test. This test is divided into three sections. First is language. Language section is further divided into section A and section B. In the language section, 50 questions will be given to you. You have to attempt 40 questions and time limit will be 45 minutes. Questions multiple choice होंगे. Exam will be online. In domain subjects, जो subjects आपके पास 12th में थे, for non-medical student, physics, chemistry, maths and computer science. For medical student, physics, chemistry, maths, biology, like this. In general test, questions will be based on current affairs, general knowledge, analytical reasoning, mental ability test, mathematical aptitude, like this. In domain subjects, there will be 50 questions. You have to attempt 40 questions. Time limit will be 60 minutes. For difficult subjects, and chemistry is one of them. In general test, 60 questions will be given to you. You have to attempt 50 questions. Time limit will be 60 minutes. In this test, there is a negative marking also. For correct answer +5 and for incorrect answer -1. तो अब हम बात करते हैं domain specific chemistry के बारे में. Chemistry is divided into inorganic chemistry, organic chemistry and physical chemistry. Inorganic chemistry and organic chemistry I have discussed already. In physical chemistry, the chapters included for this test are, these are the 5 chapters included in physical chemistry for this test. These 3 chapters I have discussed already. Today we will discuss chemical kinetics and surface chemistry. For this test in 2024 there are some changes. जो अभी आपको मैंने 3 sections बताए थे, you can opt maximum 6 tests. और जो general test है, it is not compulsory for all courses. तो बच्चों चलो करते हैं start chemical kinetics. What is chemical kinetics? In chemical kinetics we study about the speeds and rates of chemical reactions and the factors which affect the rate of chemical reaction and the mechanism by which the reaction proceeds. Like other videos, we will discuss these units through multiple choice questions, matching type questions and true false statements and language type questions. इसी type के questions exam में आएंगे और इसी type के questions हम discuss करेंगे. Question number 1 is the elementary reaction 2A plus B giving 3C. The rate of appearance of C at time t is given to us. We have to find the rate of disappearance of A. This is the reaction and we can write the rate of reaction in terms of disappearance of A, in terms of disappearance of B, in terms of appearance of C. Rate of disappearance of A is equal to minus dA over dt. This is the instantaneous rate of disappearance of A. We put negative sign for reactants because initially the concentration of reactants is high. As the time passes, the concentration of reactants decreases. Similarly, rate of disappearance of B. What is instantaneous rate? Change in concentration at that particular instant of time. Time interval is approaching to 0. Similarly, the rate of appearance of C is equal to, C is a product, we will put plus sign. Initially there is no product. As the reaction proceeds, concentration of product increases. But these rate of reaction are not equal. In this reaction, the rate of disappearance of A is double than the disappearance of B. Rate of formation of product C is 3 times than the rate of disappearance of B. तो इनको इक्वल करने के लिए हमें क्या करना पड़ेगा? तो जो भी स्टोइचियोमेट्रिक कोएफिशिएंट है उससे हम डिवाइड कर देंगे. Now these are equal. क्वेश्चन के अंदर हमें क्या दिया हुआ है? रेट ऑफ अपीयरेंस ऑफ C. This value is given to us. और हमें क्या निकालना है? रेट ऑफ डिसअपीयरेंस ऑफ A. हमें ये कैलकुलेट करना है. तो व्हाट विल वी डू? दिस वन. ये हमने इस यहां से उठाया है. Value of rate of appearance of C is 1.3 into 10 raised to the power minus 4. We will put this value here, mole per liter per second. We will ignore this negative sign. Mathematically इस sign की कोई importance नहीं है. Minus sign and plus sign are used to indicate कि कौन reactant है और कौन product है. Rate of disappearance of A will be equal to 2 by 3 into 1.3 into 10 raised to the power minus 4. Now solve this and the answer comes this one. So C is the correct answer. Next question, a reaction is of first order in reactant A and of second order in reactant B. तो क्वेश्चन से हमें ये पता चल रहा है कि there are two reactants. A reacts with B and products are formed. According to the law of mass action, rate of the reaction will be equal to, this is rate constant, this is concentration of reactant A and concentration of reactant B. क्वेश्चन में हमसे वो क्या कह रहा है, रिएक्शन इज ऑफ फर्स्ट ऑर्डर इन रिएक्टेंट A एंड ऑफ सेकंड ऑर्डर इन रिएक्टेंट B, तो यहाँ पर आएगा 2. If we consider the concentration of reactant A is A moles per liter and concentration of B is small b mole per liter. So in terms of small a and b, the concentration of A and B is doubled. Means A से 2A हो गई और B से 2B हो गई. It becomes, the rate of the reaction becomes 8 times. This is the correct choice. Next question, this is a statement type question. Statement 1 is given to us. The order of the reaction can be 0 or fractional. This statement is true. I will give you examples. And statement 2 is we cannot determine order from the balanced chemical equation. This is also true. Fourth option is true. This reaction is of 0 order where the decomposition of ammonia is taking place in the presence of platinum. So the concentration of ammonia on the surface of a metal remains same. Therefore, this type of reaction follows 0 order reaction. Hydrogen combines with bromine to give hydrobromic acid. The order of this reaction is 1.5, fractional order reaction. और second statement हमारी क्या थी? We can't determine the order of reaction from balanced chemical equation. Yes, this is true. We can determine molecularity of the reaction. We can't determine order of the reaction. For example, देखिए ये सामने हमारे equation लिखी हुई है. The molecularity of this reaction is 2, but the order is 1.5. So order can be determined only experimentally. Next question. 2 columns are given to you, 2 lists are given to you और आपको match करना है. 4 options हमें given है. Which is the appropriate answer? First is units of rate constant. These are the units of second order. Half-life time is equal to initial concentration divided by 2K. K is the rate constant. This half-life is for 0 order. In the third case, half-life time is plotted against the initial concentration of reactant. This is for first order. For the first order reaction, half-life time is equal to 0.693 over rate constant. Half-life time is independent of the initial concentration. Therefore, we get a straight line parallel to x-axis. Fourth is acidic hydrolysis of ethyl acetate. This is pseudo first order reaction. Pseudo first order reaction means the reaction which seems to be second order, but it is first order. This type of reaction called as pseudo first order reaction. The most appropriate answer is A. I will explain you this one. How the units of rate constant for second order is liter per mole per second. Yes, for second order reaction, rate is equal to K, concentration of A, concentration of B. 2 reactants are there. Rate constant is equal to rate over concentration of A and concentration of B. What are the units of rate? Mole per liter per second. And what are the units of concentration? Mole per liter. So mole per liter cancel हो गया. So these are the units of second order rate reactions. Now I will explain you this one. This is the integrated rate expression for 0 order reaction. This is the initial concentration of reactant. This is the concentration of reactant at any instant of time. T is the time and K is the rate constant. Half-life time means when the initial concentration becomes half, and time required to convert initial concentration into half is called as half-life time. Then the reaction becomes A naught by 2. Then the reaction becomes this. Now solve this. Next question is, by observing the graph, this graph is given in the question, the order of the reaction and slope of the line. Answer is this. First order integrated rate equation is, this is first order integrated rate equation. K is the rate constant, T is the time, A naught is the initial concentration of reactant and A is the concentration of reactant A at any instant of time. Now we arrange this equation like this. In this graph, log of A naught over A plotted against time. Then what will be the slope of the reaction? K over 2.303. This will be the slope of this line. And this is first order integrated rate equation. This will be the answer. Next question. The following data was obtained for chemical reaction. Nitric oxide reacts with hydrogen. Nitrogen forms and water forms. These data are given to us. We have to determine order of the reaction. Rate law expression for this reaction will be rate is equal to K is the rate constant, concentration of nitric oxide, X is the order of the reaction with respect to nitric oxide, and Y is the order of the reaction with respect to hydrogen. We will consider these two observations. यहाँ से we will put the concentration of nitric oxide, hydrogen and rate in this equation. Similarly for the second observation. These are the rate law expression for observation A and for observation B. अब हम क्या करेंगे? We will divide them. Rate constant cancel हो गया. Concentration of hydrogen cancel हो गई. The equation becomes, means the order of the reaction with respect to nitric oxide is 1. This will be the answer. Order of the reaction can be determined experimentally only. ये उसी का example है. Next question. In this first order reaction, decomposition of nitrogen pentaoxide takes place to give nitrogen dioxide and oxygen. Question में हमें given है this reaction is of first order. Initial concentration of N2O5 is given and the concentration after 1 hour is given to us. We have to find the rate constant. तो हम क्या करेंगे? First we will write the first order integrated rate expression. K is the rate constant, T is the time, A naught is the initial concentration of N2O5 and A is the concentration of N2O5 after 1 hour. We will put all these values. Choices में हमें minute inverse में given है और time हमें 1 hour है, तो we will put here in minutes. तो K is equal to 2.303 divided by 60 log of mole per liter. Now calculate this. The equation becomes this. Now next step, log of 3 is 0.477, log of 2 is equal to 0.3010. Put these values here and solve. On solving, value of rate constant comes 6.909 into 10 raised to the power minus 3. Very closer to this, 7 into 10 raised to the power minus 3. Question is, the rate of reaction double when its temperature changes from 300 Kelvin to 310 Kelvin. Activation energy of such reaction will be, first we will write Arrhenius equation. This is the Arrhenius equation. K2 is the rate constant at 310 Kelvin. K1 is the rate constant at 300 Kelvin. EA is the activation energy. R is the gas constant. T2 is 310 Kelvin. T1 is 300 Kelvin. We will put all these values here. अब देखिए the rate of the reaction is double when temperature changes. तो K2 becomes double than K1. तो क्या आ जाएगा? log of 2. Activation energy हमें calculate करनी है 8.314. 1 over 310 minus 1 over 300. Calculate this. Log of 2, 0.3010. This will become, solve this, the value of activation energy comes equal to 53.6 kilojoules per mole. The answer is A. Now next question. The energy of activation for forward and reverse reaction is this: A2 plus B2 giving to AB are 180 kilojoules per mole and 200 kilojoules per mole. When this reaction is done in the presence of catalyst, activation energy decreases for forward reaction as well as for backward reaction. First we will draw the graph for this reaction. This is energy of reactants. This is energy of products. This is activation energy for forward reaction. The value for this is given 180 kilojoules per mole. And this is A, this is B, and this is C. AC is the activation energy for backward reaction, that is 200 kilojoules per mole. AB is the activation energy for forward reaction. Now, in the presence of catalyst, both the activation energies decreases by 100 kilojoules per mole. So, in the presence of catalyst, क्या हो गया? This will be the graph. And in the presence of catalyst, there will be no change in the energy of reactant and product. Consider this point as D. Now, BD is the activation energy for forward reaction in the presence of catalyst, that is 80 kilojoules per mole. And for backward reaction, CD becomes 100. The enthalpy change will be activation energy for forward reaction minus activation energy for backward reaction. It will be minus 20 kilojoules per mole. This negative sign indicates that reaction is exothermic in nature. The answer will be C. Next question. 4 statements are given to you. We have to find which are correct. First statement is increase in concentration of reactant increases the rate of zero order reaction. This is false statement. Rate constant K is equal to collision frequency A if activation energy is 0. This is right statement. If we draw the graph log of K versus temperature, it is a straight line. This is wrong. If we draw the graph log of K versus 1 by T is a straight line. Yes, this is correct statement. A. First we will write Arrhenius equation. K is equal to A. This is Arrhenius equation. This is collision frequency. This is rate constant. This is exponential function. EA is the activation energy. R is the gas constant. T is the temperature. On taking log on both the sides, equation becomes this. Okay. Second statement, rate constant K is equal to collision frequency A if EA is equal to, if activation energy is equal to 0. तो अगर activation energy 0 हो गई तो rate constant becomes equal to collision frequency. Fourth क्या है? If we draw the graph log of K versus 1 by T, we will change this equation into Y is equal to mx plus C. So if we draw the graph between log of K on y-axis, 1 by T on x-axis, we will get a line. Slope of this line will be, this will be the slope of this line. Now we will do some questions from the next chapter, and that is surface chemistry. In surface chemistry, we study about the phenomena taking place on the surface. सरफेस फिनोमिना को समझने के लिए एक छोटा सा हम एक्सपेरिमेंट डिस्कस करते हैं. हमारे पास एक गैस जार है. दैट गैस जार is filled with ammonia and gas jar is connected to manometer. With the help of manometer, we can determine the pressure of ammonia gas inside the gas jar. Gas jar के अंदर हमने एक चारकोल का पीस रख दिया. After some time, when we check the pressure of ammonia gas in the gas jar, it decreases. तो अमोनिया के molecules कहाँ चले गए? The molecules of ammonia get adsorbed on the surface of charcoal. Question is, 2 statements are given. First is assertion and second is reason. Sulfur dioxide gas is adsorbed to a large extent than hydrogen on activated charcoal. Reason, sulfur dioxide has higher critical temperature than hydrogen gas. Both A and R are correct. And reason is the correct explanation of statement 1, that is assertion. Higher is the critical temperature of a gas more will be the rate of adsorption on the activated charcoal. Now, what is the critical temperature? The minimum temperature above which the gas can't be liquefied. However, high pressure we may apply. Critical temperature अगर ज़्यादा होता है तो gas can be easily liquefied. Next question, which one of the following is correct for the adsorption of a gas at a given temperature on a solid surface? This one is correct. Delta H is less than 0. Delta H will be exothermic. And delta S entropy change is also less than 0. Means randomness of the molecules decreases. This is a gas jar. इसमें कोई gas filled है और ये charcoal का piece हमने इसके अंदर रख दिया. The molecules of the gas taken in the gas jar gets adsorbed on the surface of activated charcoal. तो molecules की randomness कम हो गई. तो there will be decrease in entropy. So in the process of adsorption, new forces of attraction are developed between adsorbate and adsorbent, and in this process heat energy is liberated. Therefore, delta H will be less than 0. So this will be the correct answer. The substance which gets adsorbed is called as adsorbate, and the substance on which adsorbate is adsorbed is called as adsorbent. तो activated charcoal is adsorbent और जो गैस मॉलिक्यूल्स चारकोल के ऊपर आकर बैठे हैं उनको बोलते हैं adsorbate. Question is, we have to find the slope of AB line in this adsorption isotherm. The equation for Friedrich adsorption isotherm is x by m is equal to k p raised to the power 1 by n. X by m, this is the amount of gas adsorbed. K and N are the constant, depends upon the nature of adsorbate and adsorbent, and P is the pressure. Now we will take log on both the sides of this equation. On taking log both the sides, the equation becomes this. This is y, this is constant, and this is x, and this is the slope of the line. So this will be the answer, and the value of 1 by n lies between 0 to 1. Next question, which of the following is not an example of heterogeneous catalytic reaction? Answer is this. In the combustion of coal, no catalyst is required. Haber's process is the process which is used to manufacture ammonia. This is the Haber's process. Reactant and products are in the gaseous state and catalyst is in solid state. This is an example of heterogeneous catalytic reactions. Hydrogenation of vegetable oil is done in the presence of catalyst nickel. Nickel is in solid state and vegetable oil is in liquid form. In the Ostwald process, which is used to manufacture nitric acid, ammonia is treated with oxygen in the presence of vanadium pentoxide. Vanadium pentoxide is in solid state. Next question. Lyophilic salts are more stable than lyophobic salts because the colloidal particles are solvated. Lyophilic salts are solvent loving and lyophobic salts are solvent hating, and lyophilic salts are solvent loving, therefore they get more solvated. Starch salt is an example of lyophilic salt. Colloidal salt of ferric hydroxide is an example of lyophobic salt. Similarly, colloidal salt of arsenic sulfide is an example of lyophobic salt. Next question, the salt given below with negatively charged colloidal particles is. Answer is C. देखिए फर्स्ट केस में क्या होता है, when ferric chloride is added to hot water, positively charged colloidal salt is formed. In this case, ferric ion gets adsorbed on the surface of ferric hydroxide. Second, in this case, potassium iodide is added to silver nitrate solution. Silver nitrate is taken in the beaker. Silver nitrate is present in large amount and potassium iodide is added dropwise. Silver iodide forms and silver iodide will adsorb silver ion on the surface. This will be an example of positively charged colloidal salt. In third case, potassium iodide solution is taken in the beaker. It is present in large amount and we add silver nitrate dropwise. Iodide ion will get absorbed on the surface of silver iodide. This will be an example of negatively charged salt. In the last case also positively charged colloidal salt forms. So answer is C. Next question, which of the following is used to prepare colloids? Brady's arc method. Ostwald process is used to prepare nitric acid. Mond process is used to purify nickel metal. Von Arkel process is used to purify zirconium metal. These two methods are discussed in the video of inorganic chemistry. आप उसमें डिटेल में देख सकते हैं ये दोनों. Brady's arc method. In this method, metal electrodes जिनका हमें colloidal salt बनाना है, gold, silver, platinum, and an electric arc is struck in between two metallic electrodes. The intense heat of arc vaporizes the metal. और जो हमने यहाँ पे डिस्पर्शन मीडियम लिया है दैट इज कंसंट्रेटेड एल्कली, उसका टेम्परेचर हमने बहुत कम किया हुआ है, तो जो वेपर्स मेटल के बनते हैं वो इमीडिएटली कंडेंस हो जाते हैं. इस प्रोसेस के अंदर जो मेटल के पार्टिकल्स बनते हैं those are of colloidal size. Question is, Kraft temperature is the temperature, this will be the correct choice, above which the formation of missiles takes place. Formation of missile takes place above a certain temperature and that is called as Kraft temperature, and at a particular concentration that is called as critical missile concentration, CMC. When soap is added in water, missile formation takes place. तो अगर सोप की क्वांटिटी बहुत कम हमने वाटर के अंदर डाली है, then soap will act as an electrolyte. This is a missile. Soap molecules, देखिए मैंने एग्जांपल लिया है सोडियम स्टीरेट. What is soap? Sodium salt of higher fatty acid. This is a soap molecule. The hydrocarbon part is pointing towards inside and polar part is outwards. This spherical arrangement of soap molecules is called as a missile. Next question is, the solution of which one of the following will be least effective in coagulation of ferric hydroxide salt? Ferric hydroxide is an example of positively charged colloidal salt. Ferric hydroxide adsorbs ferric ion. तो फेरिक हाइड्रोक्साइड का जब हम कोएगुलेशन करेंगे, कोएगुलेशन का मतलब क्या है, फेरिक आयन की जो लेयर है इसको हमें खत्म करना है. फेरिक आयन इज पॉजिटिवली चार्ज, तो इसे कोएगुलेट करने के लिए हमें क्या चाहिए, एनायन चाहिए. तो हायर द नेगेटिव चार्ज मोर रेडिली कोएगुलेशन विल टेक प्लेस. तो इन 4 केसेस के अंदर देखिए, इन दिस केस it will ionize to give, so this anion will coagulate readily ferric hydroxide salt, and least effective will be the one which is having least negative charge, and that is KBr. So answer will be KBr. Next question, the process that uses homogeneous catalyst is hydrolysis of ester. In this, reactants, products and catalysts all are in same physical state, that is liquid state. Question is, match list 1 with list 2. This question is related with the preparation of colloidal salt by chemical methods. Hydrolysis. Ferric hydroxide salt is prepared by the hydrolysis of ferric chloride. Reduction. This one. देखिए, the oxidation state of gold changes from +3 to 0. Oxidation. Oxidation, this one. The oxidation state of sulfur increases from -2 to 0. Double decomposition, this one. So answer is this. Next question, Tyndall effect is more effectively shown by lyophobic colloid. Because lyophobic colloidal salts are not solvated, and therefore the difference in the refractive index of dispersed phase and dispersion medium is large, and when the light is passed through the lyophobic colloidal salt, the path of the light gets illuminated. I will show you Tyndall effect by doing one experiment. Through this experiment, I will show you that Tyndall effect is more effective in lyophobic salts than lyophilic salts. I have taken these 2 beakers. In one of the beaker, in this beaker, I have taken lyophobic colloidal salt, that is metal sulfide salt, and in the other beaker I have taken lyophilic salt. Now, when we pass light through lyophobic colloidal salt, just see, scattering of light is taking place. The path of the light is visible. So Tyndall effect is more effective in lyophobic colloidal salt. When we pass the light through lyophilic salt, Tyndall effect is taking place, but not much effective as in the case of lyophobic salt. तो लास्ट क्वेश्चन बच्चों, आप समझ आ गया होगा थ्रू दिस एक्सपेरिमेंट. तो आज की वीडियो हम यहीं पर खत्म करते हैं. मिलते हैं नेक्स्ट वीडियो में. जिस टाइप के क्वेश्चंस हमने डिस्कस किए हैं, आप भी इसी टाइप के क्वेश्चंस की प्रैक्टिस करिए. और जो क्वेश्चंस मैंने डिफरेंट वीडियोस में डिस्कस किए हैं, इनऑर्गेनिक केमिस्ट्री, ऑर्गेनिक केमिस्ट्री, दिस इज द थर्ड वीडियो ऑन फिजिकल केमिस्ट्री. यू कैन गो थ्रू दीज वीडियोस फॉर अदर एग्जाम्स आल्सो. तो मिलते हैं बच्चों नेक्स्ट वीडियो में.